All right, CNT140, we're looking at Chapter 1, and we're looking at computer networks. Now, the book reminds us about computer network development. Again, we're looking at cable design, as we're moving data around now on computer networks, what was necessary cabling-wise to do that. Keep that kind of in your focus. So, as we move into the 1940s, I threw in here John Newman, working on the Eniac. He introduced the concept of basically storage, modular computing and storage of information. And here's a picture of John Newman and the Eniac. What we start having develop as the big first computers, because we need things to calculate many things very quickly. And a lot of this was on calculating ballistics, and then eventually as we get into World War II, we start having machines calculating, trying to figure out encryption and crack encryption, doing multiple calculations very quickly, trying to come up with options for. So the development of the first computers was necessary for doing lots of these calculations for ballistics, doing lots of calculations for figuring out encryption. Interesting side reads if the history of computing is interesting to you. And here's pictures of the first Eniac computers. Along come the second generation and first and second generation computers, 1950s. First generation was vacuum tubes. Second generation, we start using transistors as semiconductors, making things smaller, more efficient, and a little bit faster. So as we have that, here we go, with the 1950s, the first and second generation, we have the UNIVAC computers. So we went from Eniac to UNIVAC. Third generation computers here, we have IBM System 360. So we're having systems like this now, doing multiple calculations quickly. As we move to the 60s and 70s, size is reducing, cost is reducing, and then we start having people like Bill Gates and Steve Jobs come on the scene, including Steve Wozniak too. Bill Gates with the idea of a simple operating system, DOS, and people like Steve Jobs and Steve Wozniak coming up with the idea of computing for the masses. We should be able to have computers for everybody. In the 70s, we have the first hobbyist computer come onto the scene, the MITS Altair. This allows people at home to start playing with the idea of a computer and what can we do with it. 1980s, we have IBM developing the first personal computer. This becomes huge for personal computing and for business use. 1982, the first Apple computer comes along, first Apple II. Again, this is starting to get computers to users at homes and even in schools. I remember using these in school. These had the two disk drives, one for the operating system and then one for the actual program you're going to run. The operating system in one, program in the other one. So you'd load the operating system over here and then you'd load your Oregon Trail over here. Okay. Along with that, also other developments in the computer languages, circuitry, floppy disks, programs, mouse, icons. All these things were developments that were not always there. Okay. The good news is we now have lots of, each person now starts controlling his or her own computing resources. The bad news is each person now controls his or her own individual computing resources. And that's where people like us start coming on the scene of helping people with their computers and problems and troubles and so forth. The problem now is connectivity or lack of it. With mainframe computers, everybody was connected to one central node. Everything was shareable. Now we move into an environment where we're all individual and we now need to move data back and forth through SneakerNet. Okay. Initially, if we had a mainframe here, everybody was connected to it. Now we're all individual, moving things around by hand. We need some type of network. And what happens in this time frame in the roughly the 80s, early 90s, actually 80s, 70s, and 80s, you have Apple computers that say, okay, we need a network for our computers, so they develop their own network using their own protocols, using their own cabling to move data around between their computers. we have IBM computers develop an IBM network, token ring network, to move data between their IBM computers, again using their own language. Xerox computers develop their Xerox network, which we call Ethernet, to move data between their Xerox computers. So everything was very proprietary at that point. Eventually, Ethernet becomes so common that all the other companies start migrating their equipment to be able to use the Ethernet network. And it was so popular and common, hopefully we remember from CNT140, because it worked well, it was pretty cheap, it was pretty easy, so everybody kind of migrated to using that. So today the majority of networks are Ethernet. Now, linking them together was accomplished by LANs or Ethernet and cabling. And here is our Bob Metcalfe. He was the brain behind Ethernet, and this actually is his sketch that he had for Ethernet, showing a common wire that all the computers are tapping into, and his idea of how to tap into that wire, showing the actual interface, your PC controller interface, and tapping into that with some type of transceiver. And this is actually the first generation of Ethernet. You have this thick coax cable and the transceiver that bolts around it that tapped into it. And then second generation with coax, thinner coax, and your B and C connectors and T connectors to make that work. And that gets us your bus network. Everybody's tapping into that common coax cable. Eventually, the coax bus goes away and gets replaced by our star network with twisted pair cabling. And the reason we did that, or reason that happened, was coax was a little bit troublesome to deal with, and tapping in and so forth. Twisted pair is much easier to deal with, much easier to terminate, and the fact that there's an individual line from every computer to this central node, their central hub and switch. If there's a problem with this link, it only affects this link, this computer, nobody else. Previously, if there was a problem with this coax cable here, it could potentially cause the whole network to fail or have issues for the whole network. So the development of this, in moving into the star with twisted pair, was kind of an evolution. So now we have local area networks allowing people in office to share files back and forth, share a printer, that sort of thing, without doing the sneakernet deal. So now we have the ability to link computers together for email, that sort of thing, moving data around, all that kind of good stuff. Video entertainment, personal video, movies, constitutes a large part of our internet today, or video traffic. Absolutely. Think about how many things we watch across our network today that we did not used to watch previously. And I just throw out Hulu, Netflix, that sort of thing as an example. Yep. Nowadays, converging our networks together is huge. We now, if we think about our computer networks, what we move across there, almost all types of traffic move across our computer network, including video traffic for television, gaming traffic, our data and email, and then including our phone as well. So what has started to happen, where companies used to have their own little phone switch for their phone system, and then computers, switches, routers out to the internet, what is now starting to happen is all of this gear is attaching to our network and moving out through our internet connection, and that's our converged networks. So the vast majority of things are moving through our network now. So the reliance on this is really huge. All right, so that was supposed to be an introduction, or kind of a reminder of history for you, introduction of all the developments leading through, and all kind of like the cable technologies developed with the phone cable and the coax cable for television and our twisted pair for networks and all that stuff. Now we're going to come back in future chapters here and start zeroing in on these cables and cable technologies and how all these things get used.